Welcome back, guys. So in this lesson we'll be looking at series of numbers. In the last lesson we look at sequence as the arrangement of numbers according to a given pattern or rule. So this is series. Okay, a series is performed when the term of a sequence are added. Okay, in short, series is the addition of sequence. So series is the addition of sequence. Okay, so when you add the numbers in a sequence together, you have a series. So a series can be finite or infinite. E.g., look at this series: 12 plus 9 plus 6 plus 3 plus 0 plus up to. Okay, this series is infinite. Okay, because the terms are unlimited. Okay, the terms continue indefinitely to infinity. So this is an example of an infinite series. So when a series is finite, the term of this series will have a ending term. So consider this example: 3 plus 7 plus 11 plus 15 plus 19. Okay, so this series is finite. Okay, and the last term equals to 19, the first term equals to 3, and the second term is 7, the third term is 11, and the fourth term is 15. So this is an example of a finite series with a last term which is 19. That is, the last term is known, but in the first one we don't know the last term, so we say it is an infinite series. Now the general term, we can find the general term of a series. Okay, so if you look at this series number 1, let's look at series number 1. We can find the general term of this one. Let's write general term. So the first term is 12, second term is 9. So the difference between the first and the second is kind of 3. Okay, so 3. Now the difference between 6 and 9 is also 3. Okay, so we have a continuous 3 somehow. Let's see if we can generate the nth term of the sequence. So let's use another sequence. Consider this one: 5 plus 9 plus 13 plus 17 plus 21 plus ... which is an infinite sequence, an infinite series rather. Okay, now let us find the general term. The first term is 5, the second term is 9. The difference between this and this is 4, so this is 4n plus 1. Okay, 4 times 1 plus 1, that's n equals to 1 here. This is 4n plus 1, n equals to 2. So the un for this sequence is 4n plus 1. Okay, so I think we should be able to generate the un for this sequence, which is 3 times, is reducing 3 into minus n, or maybe plus 1 rather, if it works. So this is the nth term of the sequence. Okay, now we can write a formula for the series. In the formula we put n equals to r. Okay, n is usually equal to r, and we take summation. Is this series finite? No, this is an infinite series because it is infinite. It is infinite, so the formula is going to be summation r equals to 1 to infinity of 4r plus 1. Okay, So this is the formula for this particular series. Okay, so we can write a formula for the series from the way we normally generate the formula of a sequence. Okay, so when you have an infinite series, you take the summation from 1 to infinity, and you write the formula inside the bracket, inside the sigma notation. Okay, so this is how to generate the formula of a series. Let's just look at the examples. Write down the first 3 terms, the last term if the series is finite, and the nth term of the following series. Okay, so let us start from A. We have summation r equals to 1 to 9, 3r minus 2. Okay, this series is finite because the last term is 9. Okay, so now the first term u1 is going to be, when r equals to 1, 3 times 1 minus 1, which is 3 minus 2, which is 1, and the second term is going to be 3 times 2 minus 2, which is 6 minus 2, which is 4. The third term is going to be 3 times 3 minus 2, which is 9 minus 2, which is 7. Okay, 7. So the last term is u9, equals to 3 times 9 minus 2, which is 3 times 9, which is 27, minus 2, which is 25. Okay, so this is the first term is 1, the second term is 4, third term is 7, and the last term, which is 9th term, is 25. Okay, we can do the same thing for B. The formula is summation r equals to 1 to 7, 2 raised to power r. Okay, so the first term here will be u1, which is 2 raised to power 1, which is 2. The second term u2 is 2 raised to power 2, which is 4. The third term is u3, which is 2 raised to power 3, which is 8. And the last term, which is the seventh term, u7 is 2 raised to power 7, which is 10, so 128. Okay, so this is how, given the formula for the series, you can find any given term of the series. Let's consider C. The formula for C is sigma r equals to 1 to n r into r plus 1. So the first term, which is u1, will be 1 into 1 plus 1, which is 2. The second term will be 2 into 2 plus 1, which is 2 times 3, which is 6. And the third term will be 3 into 3 plus 1, which is 3 times 4, which is 12. So the nth term, un, will be n into n plus 1. Okay, that is the last term of the sequence is n, so it is assumed to be infinite if n is known. So un equals to n into n plus 1. So we can take question D. The formula for the sequence is r equals to 4 to 10, r squared plus 2r plus 1. Okay guys, this is a finite sequence because the last term, the summation is taken from 4 to 10. Okay, so u1, we are starting from 4, so there's no u1, so we have u4, which is r equals to 4. Now 4 squared plus 2 times 4 plus 1, which is 16 plus 8 plus 1, which will give us 25. U5 is 5 squared plus 2 times 5 plus 1, which is 25, plus 10 plus 1, which is 36. And then we have U6, which is 6 squared plus 2 times 6 plus 1, which is 36 plus 12 plus 1, and which is 48, which is 49. Okay, so you can see the pattern, the squares of numbers from 5 up to 10. Squares of number from 5 up to 10. So the last term, which is U10, will be 10 square plus 2 times 10 plus 1, which is going to be 81, guys. 100 plus 20 plus 1, which is 81. No. It's not 81, it's 121. Yeah, 121. So if you take the square of the previous term, if you this previous term will give you the next term. Okay, yeah. So this is for this one, and then we are done with that. Work out the 15th term in the series. So the formula for the series is sigma r equals to 1 to infinity of 2r plus 1. It's an infinite series, infinite. Okay, so the 15th term, u15, will be taken when r is 15. So that will be 2 times 15 plus 1, which is 30 plus 1, which of course is 31. So the 15th term of the series is 31. Another example, write the following series using the sigma notation. Okay, if we want to write the series in sigma notation, we must know how to generate the nth term of the series, and then we can write it in sigma notation. So we use the method of writing the nth term of a sequence also. So for A, we have the first term to be 2, we have the second term to be 5. The difference between the first and the second is 3. So we can generate the pattern by saying 3 times 1 minus 1. This is 3 times 2 minus 1, and 8 is 3 times 3 minus 1. So of course we can take it to n, un, which is 3. First term is 3 times 1, second times 3 times 2, 3 times 3. So of course this is 3 times n minus 1. So un equals to 3 n minus 1. Therefore, the formula, so the formula for the nth term will be r equals to 1 to infinity. It is infinite, okay, because of these 3 dots. This implies infinite. So of the formula, change n to r, we have 3r minus 1. And that gives us the formula. We can generate for B 1, 4, 9, 16, 21. So this is 1 plus 4 plus 9 plus 16 plus up to 121. Okay, let's check. Yeah, so of course we have a last term here. This is a finite series. So let us generate the n term. So this is 4 and this is 9. So we put 1 square here. This is 1 square, 2 square, 3 square. For 16 we have 4 squares. So of course we can do it up to un, which will be n square. Okay, so the formula for this series, of course the last term, which is the last term, the u11, is 11 squared. So we are taking the sum from r equals to 1 to 11 of n squared, r squared. So this is the formula. Given that sigma r equals to 1 to 4 of 6r equals to 2 sigma r equals to 1 to n of 5r. Work out the value of a. Now we'll start from the first one. We compare the terms. So what we have is sigma r equals to 1 to 4 of 6r equals to 2 sigma r equals to 1 to n of 5r. Okay, yeah. So this will give us, compare the terms. When r equals to 1, we have here 6 equals to 2, okay, 2 times 5. Okay, we should be able to find that anyway. Let's take it this way. So we are stopping at 4 here. R equals to 4. So we have 6 times 4 equals to, up to this one, 2 into 5. 4 is the last term here. So since this one started from 1, s as n of this one will be 4 as well. So 6 times 4 is 24 equals to 2 times 5, which is 10n. So 10n equals to 24. Okay, so n equals to 24 over 10, which is 2.4. Okay, yeah, 2 here 5, 2 here 12, stop by 4. So n equals to 2o number 4 over 10, which is actually 2o number 1 over 5. Alright guys, so this is the end of this lesson. See you in the next video. Bye. Please hit the subscription button.